As we have seen in my matrices introduction video, there are a number of different uses for matrices in real life. You might recall that a matrix can be thought of simply as a table of numbers with a given number of rows and columns. Really, matrices are just another way that we can display data. Given this, common sense tells us that sometimes there might be a need to add or subtract matrices from each other. In this video, we'll look at matrix addition, matrix subtraction, and properties of matrix addition. Matrices can be added and subtracted from each other. However, they can only be added or subtracted from each other if they have the same order or dimensions. Matrices of different orders cannot be added or subtracted. Remember that order or dimension is the number of rows m and the number of columns n a matrix has. An m by n matrix has m rows and n columns. The result of the addition or subtraction is another matrix of the same order. Matrix A plus or minus matrix B equals the corresponding elements of matrix A plus or minus the elements of matrix B. Let's look at an example. Remember to add two matrices, they must have the same order. Here we have two 2 by 3 matrices. They are the same order or dimension. To add them, you simply add the corresponding entries. So we write matrix A plus matrix B equals, and then we add the elements in the matrices. We find that the result is a matrix of the same order where all the elements have just been added together. Let's look at another example. Here we have matrices of both 3 by 2, therefore we can add them together. We have matrix A plus matrix B, and we add the corresponding elements to each other, and we get the solution of matrix A plus matrix B. The maths here isn't very difficult. Let's look at a subtraction example. Again, we have two 2 by 3 matrices, so we subtract one from the other. This time we subtract from matrix A the corresponding element from matrix B. We write matrix A minus matrix B equals, and then we can rewrite the matrix with the subtraction of the corresponding elements within the matrix. And we can finalize that and we get a matrix of the same order. A local cafe sells 2 types of energy drinks that come in 3 different sizes, small, medium, and large. A stock take was completed at the start of the week and at the end of the week, and the results were as follows. At the start of the week, we had drink A and drink B, and you have small, medium, and large, and you've got the quantity of each. At the end of the week, again, we've got drink A and drink B, and the quantity of small, medium, and large of each. And you can see how we've already started to represent that in a matrix. If no stock was purchased during the week, how many of each size drink were sold? Now, can we use matrix operations to work this out? So the sales during the week is going to be the stock at the start of the week matrix less stock at the end of the week matrix. So I've labeled them matrix S and matrix E. So we're going to take away matrix E, the end of the week, from matrix S, which is the stock at the start of the week. We take away the corresponding elements, so our 2 matrices were of the same order, and we can simplify and we get this matrix here. At the end of the week, we can say that we sold 14 small drink A's, 25 medium drink A's, and 16 large. We sold 6 small drink B's, 10 medium drink B's, and 19 large drink B's. A zero matrix is an m by n matrix in which all the elements are zeros. If we add a zero matrix to a matrix, the result is the original matrix. Here we have matrix A, and we've got a zero matrix. They're of the same order, and therefore they can be added together. Common sense says that when we add all of the elements, it's going to still equal matrix A. If we add matrix A to the negative of matrix A, we get a zero matrix, or matrix O. Matrix A plus the negative of matrix A, we add them together. We can add all of the corresponding elements, and we're going to get a zero matrix. Here are some of the properties of matrices. The first one we've already been over. Matrix A plus matrix B is going to equal matrix C. We've got matrix A plus a zero matrix equals a zero matrix plus matrix A, which equals matrix A. It's the additive identity property. We've got matrix A, add the negative of matrix A is going to be a zero matrix, which is the additive inverse property. We've got matrix A plus matrix B is equal to matrix B plus matrix A. That's a commutative law. And then we've got matrix A plus, in brackets, matrix B plus matrix C is going to be the same as adding matrix A and B and then adding matrix C, which equals matrix A plus matrix B plus matrix C. That's the associative law. So in summary, we've had a look at what matrix addition is, what matrix subtraction is, and the properties of some matrix addition. Thank you.